Good morning. Today I'll be trying my hands on Science Class 10 MBSc. The first chapter of physics, you have light, reflection and refraction. The chapter is light, so inside there we will be studying mainly reflection and refraction. Okay. Light, reflection and refraction. These are the two topics mainly, broadly it is inside there. Right, this is chapter 1, class 10. You all know that light is a form of energy, just like other forms of energy. Form of energy. Energy, of course, can be converted from one form to the other, and it cannot be destroyed, it cannot be created. Okay, it can be only transformed from one form to the other form. Suppose it is a light energy, it will be converted into sound energy, it will be converted into electrical energy, it will be converted into chemical energy, all this way. In fact, all the process that we see around us is conversion of energy only, which is going to happen. The debate is long, with a lot of discussion, which is beyond the scope of your class 10 syllabus. So we'll stick here that it is a form of energy. What is light? That itself is a big process. Einstein, in fact, once he said that for the rest of my life, I'll reflect on what light is. Okay, so he said that his life was also not enough. Whole life was not enough to describe what light is. Okay, so you can understand this is a mysterious thing. So in our case, we'll say that it is a form of energy. Now, we use light every day in many ways, not for finding out our ways around or seeing where things are. You cannot see these things here if there is no light here. Light is heading here, it is falling here, and it is coming to my eyes. So light is very important to see things. Imagine a world which is totally dark, you cannot see anything. So how important is light, you can easily understand here. So there are phenomena which are responsible for making us see, and other phenomena which can make us see different things. These are called reflection, refraction, and many other things. Okay. In this chapter, what we will be seeing is reflection. This is the topics to be discussed. Spherical mirrors, lens. All these things will be discussed in this chapter, refraction. This will be the common things will be coming into contact again and again. Okay, so first of all, we'll start our lesson with reflection. It is simple. Reflection is nothing but bouncing back. If something is hitting here, it will bounce back. Similarly, light also does this. If light is coming here, hitting, finding any object, if light sees any object there, it will head it and get bounced. Okay, so that is called reflection. When light touches something and comes back, this is called reflection of light. Okay, reflection of light. So we will write the definition also exactly same what I just told you. The bouncing back, B-O-U-N-C-I-N-G, bouncing back of light. You are going to write all these things. Light is called reflection of light. Clear? That means when you hit something, coming back, bouncing of tennis ball, your bouncing of light is called reflection. Okay? In the bouncing of light, in the reflection of light, there are some of the things which we have to write there. Suppose this is a surface, any surface, okay, any surface. where light, suppose the light is coming from somewhere here, and suppose there's light coming here, hitting anything here, and it is not going through here, bouncing back, bounce back like this. This is called incident ray of light, or simply incident ray. This is called reflected ray. Okay, this may be a mirror. Mirror is the best reflector, you can say. So this is reflecting surface. Okay, these are the things. And there this point, I call it O. O, the name of O is point of incidence. Okay, because incident light hit here, point of incidence. Okay, there are other things also. We draw a perpendicular here, straight line. So this is called, ON is called, in the same diagram, okay, ON is called normal. Why normal? Normal means perpendicular, okay. Normal is perpendicular to the surfaces, 90 degree. This angle is 90 degree from here to here. From here to here it is 90 degree. From here to here 90, because this is 180 degree straight line. So this side 90 means this side will. So ON is the normal. All these are imaginary, okay. Now reflected ray is all there, everything there. Now this is usually mirror, I told you. Mirror, reflecting surface is the mirror. Incident ray of the light is coming, reflecting here. Now why this normal is important? Normal has some work. When we measure the angle, this is I, this is R, angle, okay, just like 20 degree, 30 degree, 40 degree, this angle and this angle. So what is I? I means small letter I, incident angle. R is reflected angle or reflecting angle. Reflecting angle. We also write angle of incidence. Okay, this also can be written as angle of incidence. This can be written as angle of reflection. More appropriate to write like this. Okay, so these are the two things. You almost know all the things now. What are there? So this normal serves that purpose. Do not choose this angle. Okay, this angle is not the one. We choose the angle which is near this normal line. Okay, this one. Suppose if you call it A here, that means AON is the angle I. If you choose it B here, this will be BON is the reflecting angle or angle of reflection, right? So these are the things about reflection part. There are some law also. Laws of reflection. Laws of reflection says that, what laws of reflection? Laws of reflection is, if you want to study reflection, these are the three things which are true. Just like theorem we did in maths, here also you have laws, which is always true when you are studying reflection. Okay, well established things. So what is that? Number one, the angle of incidence is equal to the angle of reflection. In short, angle I is equal to angle R. I'm not writing the symbol, okay. That means this angle is always going to be equal to this. This is the law of reflection. Every time you study reflection, this is true for any reflecting surface. This may be mirror, this may be a cloth, this may be a blackboard, whatever it is. The reflection is going to follow this. 30 degree, this will be 30 degree. 60 degree, this will be 60 degree. 90 degree, it will be 90 degree. Okay? So this is the law of reflection, number one. Number two is also important. Number two says the incident ray, the first one, incident ray. Look at there, imagine that. The reflected ray, the second one after hitting here, reflected ray, and one more thing, and the normal. And the normal is not a ray, okay? This is just line, imaginary line. So that is why we don't write ray. Normal at the point of incidence always lie on the same plane. This is important to understand. That means if this is going here and this is going here, the middle one, it will always come in the same line, just like this board, whiteboard, same line. It is not that incident light is coming from here, normal is here. Okay, you understand? See, this is incident light from here, in my hand direction, and the normal is there. Okay, the plane becomes this one. This is not true. This is the plane. No, that is not true. And then the third one is coming here. No. If incident ray is coming from here, the normal is here, the reflection will be here. Not like this, not like this. This is not true. Okay, for one incidence point, this should be thought as in the same line. So that is why it is easy to make and easy to study. Okay, it is these are the two laws which is important. More than the definition, the understanding is important, so that it will be easily coming in your memory, right? This will play a vital role in understanding mirrors, because a lot of questions are asked in mirrors, numericals, or even for the derivation of mirror formula, etc. All these are used. Okay. Next topic is optical image. You all know what is image. When you see inside the mirror, you'll find your image, isn't it? So that is image. And apart from that, how it is made, what causes the image to form. So that we want to study here. We say after reflection, we are studying reflection, remember? After reflection and refraction, in both the cases, when the rays meet or appear to meet, image is formed. Okay, now what are the types of image? The real image. The real image is, you see, appear to meet means virtual, not real. Actually meeting is real. You will know in the examples how it is done. So real image is one side, the other side is virtual image. Okay, two different parts of the image. A real image, from the name itself, it suggests that real image is something which is real in its visibility as well, and virtual is usually by the lines which are appear to be meeting, not actually meeting. Okay, so there are some basic differences formed when rays actually intersect. Many things I have not written down in detail. Rays means incident angle or the reflected angle or refracted angle. Formed, here it is formed when rays appear to meet. Okay, meet means intersect again. Number 2. Real image is inverted. Very important. Real image is always inverted. Suppose I'm standing like this. This is my head. This is my leg. Okay. This is my head. This is my leg. Then my image, if it is real, it will be looking like this. The head will be down. Toe will be up. Okay. So this will be your real image characteristic. The property of real image. It is formed in front of mirror. It is formed on the other side of lens. These are the differences. This side, it is formed on the other side of the lens. If it is lens, other side. Object here, image will be that side of the lens. It is formed in front of the mirror. If this is a real image, if I see here, the image also will be coming this side, not inside the mirror. Okay, we'll come to know slowly how it is done. Real image is inverted. Virtual image is erect. Erect means if this is the object, the image will also be like this. Okay, same way. So the head is up, always up, even in the image also. Number 3. It is formed behind the mirror. In the mirror, it is found behind. It is formed on the same side of the object. If the object is left side, the image will also form left side in case of virtual image. Okay, so we have seen what type of images are there. Still we have to do practical thing, that means the making lines, this, that, everything is going to come slowly and slowly. This will look meaningful, more meaningful with those images created. Okay, when you are revising, all these things need to be looked into detail with your textbook on and try to read all the lines that is given, because these are limited informations. What you're studying is also not fully given. Okay, many things you have to start thinking by yourself also. When you're studying science, not just the book content is important, the brain has to work, otherwise you'll not be understanding the things. Mirrors. Now first character that comes to play with reflection is mirrors. When mirror is there, you'll understand what is reflection very easily. What is mirror? Where we see our face daily, that is mirror, isn't it? But there are different types of mirrors also. So how to define it very scientifically? Look at the meaning. A smooth, highly polished, you cannot deny it is not smooth, isn't it? Very smooth, highly polished, capable. It can do what? Capable of reflecting maximum amount of light from its surface. Is called mirror. See, in our day-to-day life, we see the mirror simply daily, this and that. But how well it is defined? Smooth, it has to be perfectly smooth, highly polished, as much as possible. You see, every mirror is highly polished, capable of reflecting, and which can do. Capable means it can do reflecting. It can hit. Light will hit and it will bounce back. You will not see mirror is there, light is coming from this side. Okay, so reflecting maximum amount of light from its surface is called mirror. So this is the definition of mirror in scientific terms. Types. What are they? Number A, plain mirror. Plain mirror is the one you see daily. Okay, plain mirror is the one. What is this? Highly polished, plain or flat surface. Example, looking glass. Maybe what you see at home is looking glass. So a diagram will be like this. This opposite side, you see the mirror from this side. Okay? You will look into the mirror like this. Okay, from the top side. This is a plain mirror. Plain mirrors discussion will not be very much, because we are more interested in the second type. Okay, in B1. You can pause the video at times to see and revisit the previous part if you are not clear. Remember what is sphere? Spherical comes from there. Spherical mirror. There are also curved mirrors. The name itself, it suggests it is plain, it is non-plane, curved, spherical. Okay, if you have a ball, that is sphere. Spherical mirror means from the ball you cut some part. Ball looks like this, isn't it? A football looks like this. Am I right? So if you cut this section, how it will look? It will look like a ball like this. Small spherical ball, B-O-W-L ball, okay? Plate. So that is spherical mirror. Right? So the whole ball, football, from the football you cut one section. You see in the football also there are sections. If you take out that part, okay, precisely. That will be called your spherical part. Right? We'll write the definition properly, what it has. Mirrors which have curved reflecting surfaces. Surfaces are called spherical mirror. Right? Now, remember, they also obey the law of reflection, because the law of reflection is for everything, not just this one or this. So you may think that I made in the diagram this and this, but even if it is like this, here also it will be following. This rule is always followed. Laws of reflection. I incident I will be equal to R. That is true even for this type, that type, every type of mirror. Okay. Now, in the case of curved mirrors, we have two different type of curved mirrors. What are they? Here, there is no type here. Here I will write the types. Number one, concave mirrors. Okay. Number two is, let's first write this. A spherical mirror. Whose reflecting surface is curved. Inwards. Number two, concave mirror. Exactly opposite. A spherical mirror whose reflecting surface is curved outside. Okay, so the examples I'll make it. This is a mirror. Okay, this is called concave. This will be called convex. Understand? See, inside. This is inside. This is outside. This is inside here. In this case, okay. Mirror whose reflecting surface is curved inward, inwards. This is plane, curved. If it is curved inside, reflecting surface is this one, not this one. Okay, this is the rough side where there is no reflection, no image you can see. From here, inside curve, and this is outside. Now, to remember easy way is cave. This word you remember, cave. If the reflecting surface looks like a cave means something like this, isn't it? Inside animals live. Animals can go inside their home. So if this looks like a cave, the reflecting surface, that is concave. The other one will be convex. Okay. So there we stop. In the next class, we try to write the details inside the mirror, more technical terms. Thank you.